All right, me again. I'm going to show you really quickly how to use this solubility rules table. This is on page 6 of your chemistry reference tables. And it looks really straightforward, but when you start using it, you can get a little bit bogged down. And so if you're going to use it sometime in the future, it's good to practice with it. And so I'm just giving you a little bit of practice with it here. Just want to demonstrate how we're gonna go through 3 compounds and find them in here and figure out what they are. But let's look at this first of all. So solubility rules, this gives us the ability to predict whether something is soluble or not. And first we have, well, that wasn't what I expected to happen. First we have a list of things that are soluble. If you look at this, nitrates, acetates, ammonium, and group 1 salt. So we're talking about ionic compounds, nitrate, acetate, ammonium. These are all ions. Salts are ionic compounds. So this is all about figuring out whether ionic compounds are soluble or not. So these are all things that have a positive ion and a negative ion. This is saying anything combined with nitrate is soluble. No exceptions. Anything combined with chloride, bromide, or iodide, those are your halogens, is soluble with a couple of exceptions, silver, lead, and mercury. Fluorides, sulfates, carbonates, hydroxide, sulfide, oxide. So this is all in terms of main group elements, main group ions, and polyatomic ions, right? The transition metals are listed only as exceptions. So if you're trying to solve a compound that includes a transition metal, you're going to need to look at what is the anion that it's combined with. Is that in the table? And then if the transition metals are only present as exceptions. I forgot to do a transition metal here. I'll try to remember to add one at the end. Okay, so let's do a couple of examples. So we have soluble on this side, insoluble on this side, carbonates, phosphates, hydroxides, with exceptions, because see, anything combined with these is soluble, so they have to be exceptions to the insoluble. So here we have sodium sulfate. So we go right up here, all nitrates, acetates, ammonium, and group 1, parentheses 1A salts. What is 1A? Well, if you look at your periodic table, you will see that that's the alkali metals, lithium, sodium, potassium, cesium, rubidium, cesium. So that means this is group 1 salt. It is soluble. We could stop there. It turns out that all sulfates are also listed under soluble, except calcium, strontium, barium, mercury, lead, and silver. So sodium is not one of those exceptions. So this one is definitely soluble. A big S next to that. All right, barium chloride. All right, so barium is one of those things that is mostly there as an exception. Well, let's see. Barium is in group 2. They mentioned group 2 in some places. All right, barium. We're going to have to look at chloride. All nitrates, acetates, ammonium in group 1. All chlorides, with exceptions, we're under soluble. All chlorides are soluble with exceptions silver, lead, and mercury. Barium is not listed in the exceptions, so barium is one of the chlorides that is soluble. So we're going to call that soluble. All right, magnesium hydroxide. Okay, magnesium is in group 2. Group 2 are listed, I think, only as exceptions. So let's look at hydroxide, 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 hydroxide. Carbonates, phosphates, hydroxides. Okay, now we have to look carefully. Hydroxides are soluble, but there are exceptions. All hydroxides are insoluble except group 1, so we're in group 2. Strontium, barium, those are in group 2, but this is not strontium or barium, this is magnesium and ammonium. So hydroxides are insoluble. Magnesium is not one of the exceptions, so we're going to call this insoluble. And that's basically what you do is you take each compound and you find in the chart, try to find the ions. Notice that the chart contains certain really common ions. Certain less common things are only present as exceptions. So don't tear your hair looking for copper or something like that. Look for the familiar polyatomic ions and the group 1 and the chlorides, bromides, iodides, sulfides, and oxides are all in this chart. All right, good luck with that.